Hello, Professor. I will make a presentation on my case study. According to the case of Toyota Motor Manufacturing, I put forward my own views on two questions. The first question is, as Dr. Friesen, what would you do to address the seat problem? Where would you focus your attention and solution effort? My answer is, through the analysis of the information in the article, the following points can be inferred. First, according to Exhibit 7, since October 1991, the defect rate of seats is very high, which all involve the most important five aspects, like missing, broken, wrong, wrinkles, and so on. According to Exhibit 10, the number of defects began to increase from April 14th. This time node corresponds to in April, Wiggins destined for Europe added another 10 variations. And on the horizon was export to Japan and the Middle East. And this would add still another 18 seat variations. But when asked about the seat problem near the front seat installation between Final 1 and Final 2, the only problem they could think of was occasional incidents of cross-threading, and they became more and more confused when asked so many questions about seat defects. According to Shirley Surgeon's statement during rail slide post installation, a hook protruding from the back of the part was to be snapped into the eye of the body. But the hook sometimes broke off. Therefore, doc needs to focus on KFS quality control and exploring the difference between the first class and the second class. First, consider the defects of the back seat, including wrong part, missing part, and other defects, and improve the quality by improving this part from KFS. And second, solve the problem of bolster hook breakage in the TMM process. The third one is exploring the reason for difference in defect rates between the two shafts and the string apparatus. And the operators in the overflow parking station need to be trained to write the seat order form. As for another question, well, if at all, does the current routine for handling defective seats develop from the principles of the Toyota production system? As for my views, the JIT inventory management system was designed to ensure a pull rather than push management principle, which reduces costs and ensures the most efficient manufacturing environment. And the team did not deviate from the JIT principle. Toyota production system on Dakota to immediately identify and solve problems in production. However, there are still deviations in the procedures for dealing with the defects of the seat problem. When the operation team cannot solve the problems, the car will continue to pass through the assembly line and the production process will not stop. And the problem is not solved in a standard way. The defect of the tagged car would either be resolved at the clinic ID area or at the overflow parking. And Kaizen was the idea of constantly seeking change for the better. Therefore, the conclusion is that neither Dakota nor Kaizen has been used well in the process of dealing with car seat defects. So this is the complete content of the case study, and thanks for your time.